Hello and welcome to the second video in the Operations Research Study Guide. Today we will be defining a linear program. Now in the last video we have already looked at a model of a bakery. Today we'll be looking at and defining more of a linear program. So once again, your objective function is to maximize or minimize a linear function of decision variables. So we have to look at linear versus non-linear. Of course, we have in linear anything from x1 times some constant c1 plus x2 times some constant c2 plus x3 times some constant 3. And this can go on for any number of enumerations. And then of course you set that equal to, you can set that equal, set that greater than, equal to, you can do whatever, but it has to be equal to some other constant. Or equal to some value on the other side. Now of course for examples of this we could have 5x plus 3y plus 4z must be less than or equal to 28. Now in any instance, a linear function is going to graph sort of like this straight line, where any value, let's say if we're looking for less than, would be shaded in this area. So that would be your inequality graph. Now we're going to look at some nonlinear. And I think it's better to just look at examples of things that are not linear. So we'll look at x squared as not linear. This would graph sort of like this. Clearly see it's not in that line shape. It could also have x times a y, which is not in this form. We could have even x divided by y, x cubed, any number of things where the decision variable is multiplied by itself and it's not multiplied by a constant. These would be non-linear. And of course, you cannot create a linear program using non-linear decision variables. Now we also need to discuss the non-negativity constraint, which we looked at a little bit in the previous video. Non-negativity. This is very basic, but you need this in every single model that you're doing. A decision variable must be greater than or equal to 0. If we have, for instance, an x plus a y must be greater than 14. Let's say this is cookies in your previous example, and this is brownies. If we do not have this non-negativity constraint, then you can have a negative number of brownies, which means that this value would be too large. And of course, you know that you can never have a negative amount of something in a model. So in this instance, we would have to have x comma y must be greater than or equal to 0, which is your non-negativity. And then of course, we are making a certainty assumption, so certainty, where you know the values that are being given are true. And this allows for the model to reflect the real world situation. So no statistics or probabilities are really used in a linear programming. We will now be discussing some linear programming graphing solutions, and then we will also be later discussing certain models. So please look forward to that, and thank you for watching, and hopefully this is helpful.